In this video, we want to evaluate the integral of the natural log of the square root of x over x. You know, sometimes when you have the natural log function together with the x variable, it could be that it's an integration by parts problem. I always like to go with a U-substitution if we can do it. Now, in this particular problem, I tried it both ways. You could let u equal to ln of the square root of x and go through the regular procedure, find your du, and try to convert this to an integral that involves the variable u. And it's going to work. The answer might look a little bit different than the way I'm going to do it, but if you use properties of logs, you can make both of them look the same. Or you can take the derivative if you want to double check to see if it works. So what I'm going to do is I'm going to let u equal to ln of x. But first I'm going to do this. I know that the square root of x, this is the same thing as x to the 1/2, which is x to the 1/2. So there's a property that allows me to take this exponent and make it a coefficient over here. So what I'm going to do is this will be the integral, the natural log of x, and then this will be to the 1/2. Instead of square root, this will be 1/2. This comes out here as a coefficient, or I can bring it outside the integral and put it out here. That's going to be the same thing. And then I've got this x here, and then this is dx. And then I continue. The other way will work too. Like I said, the answer might look a little different, but it turns out to be the same result. So then here I'm going to let ln u equal ln of x. So the derivative on the left side will be du. Derivative of ln of x is always whatever this is x times the derivative of x. That's 1. That's 1 over x. This will be dx. So I can multiply through here by x. So I get x du. X cancels over here. I get 1 dx, so I'll just put dx. Then I'm ready to make my substitution here. This is equal to 1/2 integral. And of course the ln of x, that's your u. I'm trying to convert the integral into one that involves only the variable u instead of x. Ln of x will be u. Still got the x down here, and I don't want the x here, I just want u. But notice what happens over here. This dx right here will be replaced by x du. So I got, this will be times x du. Now this x and this x will cancel. I still got the 1/2 out front. And this will be the integral of u du. Now this is just a simple integration involving u, the variable u. So integral of u with respect to u, what do? Add 1 to the exponent here and divide by that. So this becomes an u squared. And then I have a 2 here, so it multiplies the 1/2 times the 1/2. This will be 1/4. Plus the constant of integration. And remember, when you do the u substitutions, you get your final answer in terms of u. You always go back to the original variable. So here we go back. This will be 1/4. And the u, remember, is ln of x. So this will be ln of x here. Quantity squared. Plus the constant of integration. This is your final answer. Now, I can check this by just going over my steps again and making sure I got the details correctly. Or I could take the derivative of this, if you have time. Obviously, if you're taking a test or something like that, you won't have time to check some of these, because sometimes checking it takes longer than working it out. But in this case, pretty straightforward. Taking the derivative of this, got to use the chain rule here because we have a quantity squared. So 2 times 1/4 is 1/2. So that comes on front. And then we subtract 1 from the 2. So that gives me ln to the first power. And then, because it's a power here, then again chain rule tells me I have to take the derivative of ln of x. So the derivative of ln of x is 1 over x. And remember, I'm supposed to get the integral, which is this right here. And I do, because let's go. Coefficient of 1/2 here. Property of laws allows me to bring it here as an exponent. So this would give me ln of x, or ln of x to the 1/2, but x to the 1/2, same thing as the square root of x. And then I got the x in the denominator, and that gives me the original integrand. So either way, you double check it here, but this is your answer. Thanks for watching. We'll see you next time.